Good morning, guys. I trust you are doing well. So, element and compound. This is our third chapter that we started since yesterday. And I have posted a link for a video you guys have watched yesterday. I'm sure you did it. And that video was just a little introduction about this chapter. And I trust you guys have watched it and have already an idea about it. So today, for my very first lesson for this chapter, I'm going to talk about the periodic table. Okay, I'm going to explain a little bit to you how to easily read the periodic table. When you're looking at it, you see so many things at the same time, so you can easily get lost. So through this video, you'll be able to understand very easily how to read and how to find any elements you are asked to, or any atom you are asked to find on the periodic table. Okay, so very good. The first thing I want you guys to know about the periodic table is in the periodic table, guys, the elements are arranged in order of increasing proton number. The proton number is also what we've called atomic number. Okay, so don't forget, all the elements in the periodic table are always, I repeat, always arranged in order of increasing proton number or atomic number. What do I mean? So please, guys, go on page 56 of your chemistry course book. You know this book already. So you go at page 56 and you will see the periodic table right there. So here is the periodic table. I'm sorry, so this highlight is when I read. This is how I always highlight to make sure I can easily find myself when if I need to get back to the same page. Okay, so this is my periodic table as you see here. Okay, so you see it has so many colors. So I say all the elements are arranged in order of increasing proton number. What do I mean by that? So when you look at all the elements here, this is an element and all these are elements. So each element has on top of it a small number written there. So that small number written on top is what we call the atomic number. So they are ordered, okay? They are ordered from 1, 2, 3, and it goes up to the last one is let me check. So the last element here is 80, it's 103. So 103. So it's ordered like that from 1 to 103. So when you look at, for example, the elements marked like let me take this helium, okay, He. You can see on top of it, it has atomic number written 2. Okay, it's written 2. And when you want to look at the next number, it will be the next row here. So the atomic number of this next element is Le. That's lithium. Okay, it's right there. I hope you can see. It's lithium, and the atomic number there is 3. And the next one after lithium is has an atomic number of 4. And the next one is here. Its atomic number it's 5. And then 6, 7, 8, 9, 10. And you go to the next row. 11, 12, 13, 14, 15, 16, 17, and so on. Okay, so this is what I say. It's ordered. It's arranged in order of increasing proton number or atomic number. So it's very easy. For example, if I ask you to look for a number, for an element that has an atomic number of 14, you just start looking at the number on top and you'll easily find number 14 and you'll be able to tell me which element is there, right? Okay. So the second thing about the periodic, what you'll find in the periodic table is that the vertical columns, okay, the vertical column of elements are called group. Vertical columns, okay, of elements are called group. What does it mean? You go again and check your periodic table. When I say the vertical column, what do I mean? It's just this. Okay, these are the vertical column as I'm showing right now. Okay, So these are called group. Okay, these are the groups, and all the elements in the same group have the same properties. They have similar properties. Okay, for example, we have this group. So all the elements that are listed in that group have the same properties. They have similar properties. Okay, so the group are named as, this is group 1, this is group 2. You skip all this region and you come here. This is group 3, group 4, group 5, group 6, group 7, and group 8. So you have 8 main group. Okay, group 1 to group 8. I'll get back to that to explain you what is it for. Okay, and the third thing I want you to know and want you to understand about the periodic table is that all the horizontal rows are called period. I repeat again, all the horizontal rows are called period. I get back to you again about this. So it's this. Okay, these are rows. It's like this. So all these horizontal rows are called periods. Okay. Excuse me. So you have 7 periods from period 1 to period 7. So period 1, period 2, period 3, it goes up to period 7. And all these elements are very important and you need to know them. Okay, so don't forget. Now the main distinction in the table is between the metals and the non-metals. Okay, the periodic table is all about metals and non-metals. What does it mean? So when we talk about metals, first you need to know that in order to find metals in the periodic table, okay, and non-metal, you will have just to understand these things I'm about to talk right now. Okay, so first thing you need to know is that metals has the following properties. They conduct electricity. First thing to know, metals conduct electricity and very easily. Okay, secondly, metals are malleable. What does it mean? When you use a hammer to hit on it, it's pretty simple. It changes, okay, its shape, but it does not break itself. Metals changes when you hit it with a hammer. Okay, that's what you need to know in a very short summary. So for non-metal, first thing to know is it does not conduct electricity at all. Okay, and secondly, when you use a hammer to hit, it does not change the shape, but it breaks into small pieces. Okay, that's the difference between metal and non-metal. So we say metal is malleable, but for non-metal it's not malleable, it's brittle. Okay, it's brittle. That means it breaks itself into small pieces. Okay, so metals and non-metals in the periodic table are separated by another type of element that we call metalloid. What's the difference? Metalloid it does not conduct electricity like metal, but it conducts electricity, but not as much as metals. Okay, it looks like metal, but it's different, because when you use a hammer to hit on it, it does not change the shape. It acts exactly like non-metal. It breaks itself. So we say it's brittle as well. So it's somehow between metal and non-metal. So when you look at the periodic table, you will easily find this. You first need to identify the metalloid element, and the metalloid element is formed by this diagonal. You see it has the brown color there. From B it goes to AT down there. So this diagonal is made of metalloid elements. Okay, So as soon as you identify the metalloid element, start from B to 80, all these elements in brown. So all the elements that are here at the left, all these elements at the left are metals, okay? And all the rest of the elements that are at the right here, on top right, are non-metal. You understand that? So all these are metals and all these are non-metal. And this diagonal is made of metalloids. Is that clear so far? Very good. So don't forget, keep that in your mind. So the periodic table is mostly about metals and non-metals. So now let's get back to the groups and the periods in the periodic table. So the periodic table, as I said, is organized into groups, okay? And we have from group 1 to group 8. And from group 1 to group 8, these groups are called the main elements group. The main elements group. And the period, I said, we have 7 periods, period 1 to period 7. So this group have specific names, okay? But group 1, group 2, group 7, and group 8 have specific name because these elements are known as, for example, for group 1 is known as the alkali metal. You can see it at page 56, okay? You can see when you look at your periodic table, you will see down there. You will see down here. Yeah, right there. When you look at this, you'll see what I'm talking about. Okay, all details are there. So group 1 is known as the group of alkali metals. Group 2 is known as alkaline earth metals. Group 7 is known as the halogens. And group 8 is known as the noble gases. Okay, noble gases. You know them already because we talked about it the days before. So don't forget, now between group 2 and group 3 of the main group elements, okay, we find what we call the transition elements. Where is group 2 and where is group 3? Here we go. Group 2 is right there. This is group 2. And this is group 3. Okay, now between group 2 and group 3, here, all these elements there, we call them the transition elements or the transition metals. Transition elements or transition metals. It's very important that you guys know about them, okay? And now electrons arrangement and the periodic table. Here you need to know that the electrons arrangements of atoms are linked to position in the periodic table. So elements in the same group have the same number of electrons in the outer shell. That's what I told you before. I said all the elements in one group have similar properties. So one of those properties is that they all have the same number of electrons in the outer shell. Okay, for example, group 1, the group is group 1. So the number of the group 1 simply means that all the elements in that group will have only one electron in the outer shell. Okay, I'll explain it further. So for group 2, you will have two electrons in the outer shell, and so on for the other groups. Okay, now for the main group element, don't forget the main group elements are group 1, group 2, group 3, group 4, group 5, group 6, and group 7, and you go till group 8. So these groups, guys, all are called the main group element, as I said, and the number of group is the number of electrons in the outer shell. That's what I said. Now the periods also have numbers. Okay, we say period 1 to period 7. So these numbers show how many shells of electron the atom has. So if you say period 1 is here. When you say period 1 is here, we have only one element, it's hydrogen. So period 1, that means that atom of hydrogen only have one shell. Period 2, that means all the elements that are found in this row will have only 2 shells. Period 3, that means all the elements at this period 3 row will have 3 shells, and so on. Period 4, 4 shells. Period 5, 5 shells. Okay, for example, for period 4 we have potassium, it's here, K. So 4 shell. When you will represent your atom, you'll see when you'll be arranging the electrons, they will all fit in, they will fit only in 4 shells, because the electron arrangement will show you that it needs only 4 shells to put all the atomic numbers, or all the electrons that are orbiting in that atom. Okay, so period 4 means 4 electrons. Period 5 means 5 electrons in that atoms. Okay, so you guys follow me. I think it took very long, I know, but as I told you in my previous video, that my previous message, sorry, that this chapter is quite long, so I ask you to take time to follow me slowly, and I try to break it down as much as I can in order to make you understand very well what I'm trying to explain you. Okay, so this is our today lesson. I wanted you to understand this theory part, and we'll move on next time on the next point, that will be trends in groups. Okay, so I'm going to post an activity for you on Portfolio, and it will be specific questions I'll be asking you, and you'll be asked to answer to these questions. Okay, so thanks for watching this video, and I hope it has been helpful for you. So thank you and take care. Bye.